Hello everyone, I'm Hemanth from Tufts University, and today I'll be presenting our work on improving cross-lingual sentiment analysis via conditional language adversarial networks. This work is jointly done with Dr. Bonan from Raytheon BBN. So I assume everyone here is familiar with the task of sentiment classification, where we are given a piece of text and we are trying to predict sentiment polarity of it. Good news is there are a wide range of machine learning models to tackle this problem of sentiment analysis. So recent success in English sentiment analysis is largely due to availability of this large-scale annotated data sets such as like Amazon product data, like Stanford Tree Bank, or like IMDb reviews data set. Are there many more open source data sets available for English language? But this is not the case for low resource languages because low resource languages lack labeled data, which is essential for training machine learning models. And it's really expensive to collect this training data from all languages of interest. To tackle this problem, we can use cross-lingual sentiment analysis, which is adapting the sentiment resource in large-scale annotated data set, such as English, to a low-resource target language. Basically, we use like source language training data, like English training data. We do a cross-lingual transfer, and then we would get a target language classifier, which achieves similar performance as source language classifier. But current state-of-the-art relies on like bilingual lexicons or like pre-trained cross-lingual word embeddings or machine translation to bridge this gap and transfer the sentiment information between the languages. However, cross-lingual supervision may not be available for low-resource languages because like it's not optimized way to collect the cross-lingual supervision for all language pairs of interest. Recently, Fang and Wong proposed a cross-lingual sentiment analysis model that does not require a cross-lingual supervision, which is called like CLI-DSA and CLI-DSA, which is cross-lingual in-domain sentiment analysis and cross-lingual cross-domain sentiment analysis. I will talk about the details about this model in the later section of the slides, but they rely the cross-lingual transfer by doing multilingual language modeling and language adversarial training. So our improvement on top of this is conditional language adversarial learning to make this cross-lingual representations discriminative for the sentiment analysis task. Regarding related work, most related work started from DANN networks, which is domain adaptation neural networks, where they do incorporated domain discriminator, which tries to classify the domains. At the same time, a classifier, which is try to separate the classes. So if you maximize this domain discriminator loss, we would get a language domain invariant features over here. That's the concept objective of this network. On top of this, there is CDAN networks proposed by Long et al. Called conditional adversarial networks. They propose two novel strategies. One is multilinear conditioning of features and predictions from the classifier, which improves the discriminativity. So by doing this conditioning, they capture the cross covariance between them. And they also proposed other method called entropy conditioning, which controls the uncertainty of classifier predictions, which ensures the transferability. Like this will mitigate the mode collapse in the initial stages of discriminator training. More related work to us is Fang and Wong's work of CLI-DSA/CLC-DSA, which incorporates multilingual language modeling. This incorporates initial LSTM cells. Each LSTM cell is AWD LSTM language model. So initially they have a shared LSTM cells and followed by separate LSTM for layers for different domains. So at the end, this encoder produces some language model features common from different languages. And they have incorporated language discriminators similar to domain discriminator from Guinea et al., where this goal is to make language invariant features over here. At the end, their overall objective is minimize language modeling loss and minimize the sentiment classifier loss, at the same time maximizing the language discriminator loss. They achieve language invariant features, so the sentiment classifier will perform similar from source and target. So regarding our model architecture, we have also employed same language model as theirs. They have employed a language discriminator to produce this language invariant features. Our improvement on top of this is conditional adversarial training. And this network utilizes the information from the sentiment classifier onto language discriminator. So basically, we have modeled this features, language invariant features, and sentiment classifier predictions together into language discriminator. So overall objective of our language model is we minimize the language modeling loss and sentiment classifier loss for all the languages. At the same time, we try to maximize the conditional adversarial discriminator loss. So now let me focus on the key idea of the CLAN networks, which is conditional language adversarial training. We learn this language invariant features from this conditional language discriminator by class condition, sentiment features, and from source language and the target language. Basically, what's happening over here is we do a multilinear conditioning to manipulate the interactions between these features and the class predictions, such that this captures the cross covariance between the language invariant features from the language model and the sentiment classifier. So at the end, we would produce a language invariant features, which are also discriminative. The previous works talks about language invariant features. This work improves by making this language invariant features discriminative for the sentiment analysis task. So this at the end, we would produce language invariant features from all the languages, and also contains discriminative information of sentiment classes. So regarding the experimental setup, we have used this cross-lingual sentiment analysis dataset called Webis dataset, which contains around 800,000 of Amazon product reviews from 4 different languages. So these 4 different languages are English, German, French, and Japanese. And each language, there are 3 domains: DVD, books, and music. So we have evaluated CLAN in 2 different settings. One is cross-lingual in-domain settings, and other one is cross-lingual cross-domain settings. This slide contains each and specific training, validation, and test set information, and what kind of language modeled for each settings. And we have utilized this unsupervised data from all language domain pairs with conditional language adversarial training. So this improved the performance by overall experimental setup is about utilizing the source language label data. We have used English as source language, and target language unlabeled data, and use small set of source language hyperparameters, and we modeled all the losses at the same time, and we reported the results of target language test set. So now let's talk about results. These previous methods till CLIDFA requires cross-lingual supervision. Requires cross-lingual supervision by providing target labels. MAN is multinomial adversarial networks, and multilingual word embeddings, MWE, both requires cross-lingual word embeddings. They use pre-trained cross-lingual word embeddings. This is some form of cross-lingual supervision. CLIDSA does not require those, and CLAN also does not require those. And you can see from the results that CLAN outperformed in 8 out of 9 tasks in this cross-lingual in-domain settings. And in cross-lingual cross-domain settings, it outperformed in 11 out of 12 tasks compared to all the previous methods. And we have also probed this language model features to see if they are actually language invariant. And we can see that they align really well for all language domain pairs. And in conclusion, we proposed CLAN for cross-lingual sentiment analysis, which makes the cross-lingual representations discriminative for the sentiment analysis task. Unlike previous methods which uses only feature information, we have used discriminative information from the sentiment classifier, which improves discriminativity in cross-lingual features. And we showed that clan outperformed in all settings in all previous methods in in-domain and cross-domain settings on multilingual, multi-domain Amazon review data set. And code is available on GitHub. Thanks for watching.